You ever start a job you think is going to be easy and straightforward and it turns out to be not that? Good day, welcome back to the studio. Our next project just arrived in the mail. I wanted to see if I could make a bronze turtle shell. I'm not sure what happened to the guy that used to live in here, but we're going to give him a really cool shell for when he comes home. Right off the bat though, this is a lot thinner than I expected. A lot of surface area, very thin. Not the best combo for molten metal. The first thing I need to do is cut the shell in half so I can mold the top and the bottom side separately. You can see how thin the shell actually is, especially when I hold it up to the light. But I also notice a problem that we're going to have to deal with in the future. Let me know if you see it yet. I used some all-purpose drywall mud to help thicken it up. Even though it says all-purpose, I doubt people ever had this in mind when they wrote that label. You notice that problem yet? So it's still very thin, but it's thicker than it was. Hopefully thick enough for the metal to go through before it freezes. I'm going to be using sand casting to get this project done, so I powder it with some powdered limestone and start filling the flask with sand. I want to pack the sand nice and tight, but at the same time I don't know how strong that shell really is, so I still want to be careful. I use a spoon to scrape any overlap sand down to the edge of the shell. I wish I had cut the shell in a different location. This undercut here is going to be a problem. It's going to grab the sand. It's not going to come out very well. So I'm just going to finish making the cope, and when I pull it off, see how bad it is and see what we can do about it. Carefully tried to pry it up, but it grabbed on pretty tight. That's not what you want to see. It grabbed really bad. Really don't know how I'm going to fix that. However, the main part of this that you're going to see is the outside. This is going to be hidden on the inside, so it doesn't matter as much. Still, it's not ideal. I'm going to try to fix it. The piece on the top still had its shape, so I just pressed that back into place. For the sides, I tried to carefully remove them and then put them back where they were. Didn't quite work out. So plan B was to sculpt it back into as close of the original shape as I could. Maybe I'll have better luck with the other side. Dang it. I'll sculpt that side too. We'll carve my gates so the metal enters in the side and vents out the other. And I'll do the same process with the skid plate. For metal, I'm going to make an alloy of tin bronze. So it's 88% copper and 12% tin. Have you seen the prices of tin lately? I wish I had stocked up. Once the copper's melted, I'll start adding the tin, and the tin melts nearly instantly. It's fun to put in, but sometimes accidents happen. That's unfortunate. You can actually watch the tin melt as soon as it hits the copper. Pretty cool. Since I prepped the top and bottom side of the shell, I should be able to pour them all at once. Holy crap, it's like a turtle fossil. That's pretty cool. As cool as it is, didn't quite make it. However, the bottom plate looks good though. Inside where I built the sand doesn't look too bad, so at least I know I can get away with it though. So close. That's not acceptable. So we'll do it again. So it's the same process, and we'll just hope it goes a little better next time. The metal was a little cold, I think, so I'm going to try to keep it a little hotter and do the same thing. Hopefully that works out. The sand grabbed even worse this time, but hopefully I'll be able to sculpt it back into an acceptable form. I know it's not going to be perfect, but it's the inside of the shell, so it doesn't have to be perfect. I had some old scrap metal I needed to melt down anyway, so it just gives me another chance to make another batch of tin alloy. Did it work? Not quite. So attempt number 2 turned out pretty crappy. The metal just didn't flow at all. But the interesting thing, you can see on the bottom side, that piece of sand that I tried to get back on there fell out of place. So there was a crack there. It was probably touching the sand on the drag, so there was no chance it was going to work. So I'll probably need to do a similar thing on the next one, but we're going to keep it oriented this way. So when the metal comes in, it'll have to climb. So we're going to do a little extra trick to give it a little more pressure to make it up the hill. So it's the same process for attempt number 3. But this time we're going to use the power of hydraulics to help us out. That is, if I can get the sand to behave a little bit better. It's grabbing so bad and the sand is getting weaker the more I use it. It's really starting to turn into a mess. I'd be lying if I wasn't frustrated by this point. This project was doomed on the first cut. These overhangs, I just can't work around them. That's not working. What I should have done is cut higher up, right near the seam. That would have allowed still opening relief on the skid plate and of the shell. But as of now, I think I just gotta cut these off. I'm out of options. So with another learning experience, bought with the payment of failure, I'm gonna regroup and try another plan. So here's another thing I didn't expect. Now these fins, whatever they're called, they give it strength and they keep it from flexing that way. But because I cut those off, when I pack the sand, I have a lot of flex in the shell. So during the packing, the shell has widened. At least the imprint of the sand has widened. Interesting. Now I've never actually tried this myself, but I'm going to fill an old soup can to raise the height of the flask. That'll give me more weight pushing down when I cast it, so hopefully it'll force the metal into the places that it needs to go. I'll prep the fins that I cut off because I still need those. Now when I poured this, I feel like not nearly enough metal went in. I tried to pour extra metal down the vent holes, and it just made a big mess. A little desperate, I tried to remove the can and pour metal down the hole, but it was just plugged off. Nothing I could do. Well, that was a disaster. Looks like I was too stingy with the gates. Tried to keep them too small. At least the smaller pieces turned out. Maybe we'll have more luck with attempt number 4. More metal went in, so that's a little promising. I really didn't think it was going to be this hard. This is a challenge. So back to the drywall mud, I tried to add another layer to give it a little more thickness. So I tried some bigger gates and some more venting. Maybe that'll work. There's about a 2,000 degree temperature difference between the molten metal and the sand, so the metal just freezes so fast. I want to see metal come up the vent holes, and when I don't see that, I try to pour metal into the vent holes. Sometimes you can get away with that, but in this case it just made a mess. And yet again, another failure. So in the next attempt, I use a welding rod to make a ton of vent holes, and I even had the metal come through the center of the shell. I'd be lying if I said I wasn't getting a little disheartened. Thought maybe if the metal entered in the middle of the shell it would have less of a distance to go and make it to the edge. You can see where it went in, how terrible the surface finish looks. That's a good representation of metal turbulence. Gosh, what am I gonna do now? I figured it out. I know what I need to do. Now the issue I'm having is that the metal isn't getting to the outer exterior of the shell, so I figure what I need is a highway system. If I carve deep gates from one side to the other so the metal goes everywhere and all around, it only has just a little bit left to go to get to the tips of the shell. I'm gonna try it. I don't want to have false hope, but I actually feel good about that one. Still no good. So my highway system didn't work. But maybe if I reshaped the highway system. If the metal enters from the front of the shell with more streamlined fingers, maybe it'll have a little more momentum to shoot itself right to the edge of the shell. And I'll add plenty of vents with a welding rod. I thought it was a good plan, but it's actually getting worse than when I started. But I'm not going to give up. There has to be a way to do this. So my next attempt is going to be a vertical pour. If you've seen my other videos, you know that a vertical pour has helped me solve problems in the past, so maybe it'll be the ticket this time too. This is a nightmare. I don't know what to do. Ow! Oh, it's still hot. At what point do I give up? I reconfigured the gates and the vents, and we're going to give this one more try. Oh my gosh, I think we actually did it. It's complete. So it finally worked by doing a vertical pour. And the last one I built these channels to try to get more metal to go in, but then I figured it was probably just taking longer to fill up because there's more space to fill in here. So on this one I didn't carve the channels because I figured maybe it would just fill up faster. The last one didn't fill out on the side. So this one I carved vents going out the bottom and out the sides, and you can see they were used and it worked. So now we have 4 pieces, top part, skid plate, and our little side wings. We gotta put it all back together. So I cut off the gates and the vents and get it ready for welding. I use my Tig Welder to tack on the pieces, and then I'll start welding the seam. Even though I'm using a silicone bronze TIG rod, it matches fairly well with the tin bronze. Okay, now the wings are back on there, we should be able to weld the skid plate back on. Next time I do a turtle shell, I'll cut it in a place where I only need to do 2 welds. Just kidding, I don't think there's going to be a next time. I use a cutting wheel on my Dremel to help grind away the welds and blend it in. The process is called metal chasing, and it can be an art on its own. It surprisingly has a nice tone. I really underestimated this project. It was a lot more challenging than I thought it would be. But in the end, we found a way to make it work. You can see there is some porosity from where the metal entered in and went down. Metal turbulence equals porosity, but I'll take it. If you made it to this point in the video, you're a true fan. Come on back for the next video, and we'll see how that project goes. Thanks for watching. Bye-bye.